The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI web sessions are recorded at ACI conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content.
Okay, the first speaker will be Mr. Lionel Lemay, and he's going to be talking about what role will concrete play in making our community safer. Mr. Lemay is a Vice President of Sustainability for the National Ready Mix Concrete Association. He manages the programs that assist the concrete producers, the contractor, design professionals, transfer concrete manufacturing and construction to improve overall sustainability of the concrete industry. Lionel has written numerous articles on concrete design and construction and is co-authored of the McGraw-Hill book, Insulating Concrete Forms for Residential Design and Construction. And he is a contributor for the FEMA 320, Taking Shelter from the Storm, Building a Safe Room for Your Home or Small Business. And anyone who was at the opening session realized that he was also just named a fellow. So congratulations, Lionel. Come on up and give us a talk.
Thanks, Bill, and welcome. So the title of my talk is Resilience, What Role Will Concrete Play in Making Our Communities Safer? And it really should be, what role will the concrete industry play in making our communities safer? As we go through this presentation, maybe that'll become evident why I've modified the title just slightly. Let's first take a look at why we even are concerned about resilience. Certainly we're worried about people's safety, right? So we live in buildings, houses, we work in buildings. And the losses from disasters have increased exponentially and will continue to do so, especially when you consider climate change. And these are mostly weather-related disasters. There are some, obviously, earthquakes that are not related to climate change, but most of these are weather-related in some way. Probably the most top-of-mind disaster was Hurricane Sandy, right? But we've all, in fact, we were here 10 years ago because of Hurricane Katrina. Still the largest cost human, well, not the largest human cost, but in recent history, and the largest financial cost disaster in our history. And but Hurricane Sandy at $50 billion and likely more. These are just insured losses, by the way. And so plenty of those losses were not insured. In terms of climate change factors, there's not a lot of evidence yet that hurricanes and tornadoes, as a matter of fact, are increasing as a result of climate change yet. There's a lot of evidence that it will eventually, but most of these other weather-related disasters are. Things like severe droughts, extreme precipitation, coastal flooding, heat waves, and so forth are attributed to climate change. But there are some other factors, and these aren't the only ones. Steve will talk about many more in his talk. But one of them is the fact that we are increasing in population and we're developing in areas that are, guess what, right in the path of every possible disaster we can think of. And so it's no wonder that more of us are being affected by these hazards, right? So basically, what you have is nature plus development equals disaster. Because before we came along, these storms, these heat waves, they were happening without us being here. But now we build in the path of these disasters, and guess what? Or these hazards, guess what? It becomes a disaster. So, going back to 1906, I know many of you remember the great San Francisco earthquake and fire. I just missed it. But this is the way we addressed the disaster, right? Which we should. We should, in fact, respond to disasters like the big earthquake and fire in San Francisco by housing people. Because after these disasters, guess what? There's a lot of people left homeless. Fast forward 100 years, and the tents have become trailers, but it's the same concept, right? It's reactive. We're stuck in this response mode. We keep building back to the same way that we always have. And really, when you think about it, it's disaster that is a failure of our society to adapt to our new environment. Because our new environment means that we are on the path of these incredible hazards. So the question becomes, how do we adapt? What are some of the things that we can do as a society to make sure that these hazards don't turn into disasters? Now, I'm going to go back and refer to this document called Pathways to Resilience. It's something that we put together along with a lot of partners in the industry. I'll show you who those are in a second. Basically, a guide for developing a community action plan. This is not unique. There are plans like this in almost every city. Sometimes they're called climate action plans to address the fact that climate change is going to affect cities. Miami would be probably the prime example. The first city in the United States that will probably be underwater in the next several decades as a result of sea level rise. But we went around the country and we did these workshops with all these partners, NRMCA, PCA, CRSI, the Insurance Institute for Business and Home Safety, the precast groups, 2 of them, along with a lot of local partners. And we went around the country and put on these workshops. Everybody was invited. Didn't matter if you were in the concrete industry, but community leaders, politicians, people that work in government. And we asked them, surprisingly, after teaching them most of the morning, the difference between mitigation and recovery, a lot of the response back was, how do you deal with disasters? The response back is mostly about recovery. It's what you do after a community is decimated by a disaster. We had to really pull out from them this idea that maybe we could do a better job up front and build communities that were more disaster resilient. So we asked them really to look at every disaster that could affect communities and come up with ideas on how they could mitigate those disasters. And they came up with a series. In fact, this guide has a whole series of things that they think communities could do to reduce the effects of disasters. The first one was strengthen the built environment. Things like voluntary community-based enhancement programs, mandatory adoption of stricter standards. Those were the 2 things that they talked about when it came to strengthening the built environment. Empower advocacy. Get involved at the local level because, gosh, that's where most of the politics happens, right? And get involved in building code and municipal politics where most municipalities have the ability to modify building codes to address specific issues. But that's a hard ask, right? How many of you, and obviously you guys are involved in the concrete codes, but my guess is most of you aren't involved in the broader building standards, building codes. So maybe some of you are, and maybe this group is probably not a good cross-section of society because you guys are so involved in standards. But most people, it's really out of their comfort zone. And honestly, it's a whole different animal than what happens here at ACI, right? ACI, it's all about concrete. Everybody understands concrete. When it comes to the building code, you have to have a big, broader understanding, and it's a whole different process. And so, this is one of the things that this group of people said, but we have to do this. If we care about our society, our communities, we have to be involved in trying to make them more resilient. And then launch an integrated dialogue. Call that a different word for outreach, marketing. You got to tell people that there's a better way to build. That you don't have to deal with places like poor old Moore, Oklahoma, that gets destroyed apparently every 5 years now, or even more frequently. So let's talk about strengthening the built environment. And Steve and I, we work together very closely, and you'll see there's some overlap in some of our presentations. But Steve usually has a lot more detail on some of these things, so I'll be skimming through a lot of this. But here's an example. You know, this building was designed by an architect. It was built to code. It passed all inspections. Is that safe? Maybe everybody got out. Maybe everybody in this building got out. I don't know. I have no clue what fire this is. Most of the time, the codes do a pretty good job of that. They get people out. That's the job of the building codes. It's not the job of the building codes to really protect property or property surrounding a property. Another example, designed by an architect, built to code, passed all inspections. Is it safe? Yeah, my guess is nobody died in this event. But clearly the house is going to have to be rebuilt. And so the idea, what we're talking about here, is really mitigation. We know how to build so that buildings don't end up being destroyed. People do get out. Not suggesting that's not the way to go, right? When a fire like this hits, you don't want to be in that house that survived, right? You want to be evacuated. Yet you want to come back to that house. All of your possessions, all your photographs, all your memories are still safe. And your building. You don't have to, by the way, who here has had to make a claim on insurance? Ever. Doesn't matter, car, house, whatever. Is that process much fun? We all buy insurance. We have a lot of it. And the hell if we ever want to actually file a claim. It's amazing. We're in the wrong business. But anyway, so mitigation. We know how to build. This building, not a concrete building, but it has cementitious and concrete exterior. It's got some stucco, has concrete roof tiles, overhangs that are protected with cement-type products. So guess what? It survived the fire. Every building around it was destroyed. This one's a concrete building. Survived Mississippi. It survived Hurricane Katrina. Every other building you can see is wiped out. So we know how to build, and this is sort of where concrete comes in, obviously. We have a product that actually is inherently resilient. It's not a guarantee, but it is inherently resilient. So what are we talking about with voluntary programs? Show of hands. Who knows about LEED? Green Building. Okay, most of you, right? That's a voluntary program, right? Nobody has to do that. Well, some government buildings have to be designed to LEED. But for the most part, in the private industry, you don't have to design to that standard. Building owners decide to do that. So can we do this in the resilience concept? Well, there is a standard called FORTIFIED. It's the Insurance Institute for Business and Home Safety's program, where they in fact have a certification program for buildings that are designed to a higher standard, basically Code Plus. They address things like hurricanes, tornadoes, earthquakes, floods, fires, severe winter weather, pretty much everything. I mean, it doesn't address terrorism, but neither do the building codes, really. So it addresses everything that's in the codes. And it's a very structured process where you identify the hazards in your area and where you're going to build a building, and then you design to a builder's guide. And this works for both residential and for light commercial. Design and construct to that builder's guide. And keep in mind that because it's based on sort of a percentage increase over existing loads, so if you're in an area that has low seismic loading, you won't be designed to some ridiculous seismic loading. You'll be designed to some slightly higher seismic loading. Same with wind loads. Almost every load is addressed this way, where it just says code plus some additional loading on top of that. So basically just adding a safety factor. And then there's some other detailing requirements as well, because obviously a lot of damage happens from things like windows leaking and roofing coming off and that kind of thing that need to be addressed. There's inspection and compliance during the process, and finally a certificate that's awarded. So, this kind of a program, though, needs some significant marketing effort. LEED started way back in the mid-90s, 1995, so it's been around for 20 years. This has not been around that long. Can't remember exactly when they started it, but and they don't have the same kind of muscle that sustainability green building. It works. There's some great examples of buildings that were built to the standard. These aren't concrete buildings. These are wood structures that were built in the Bolivar Peninsula of Texas. They survived Hurricane Ike. And so it just elevates the resilience of all structures. Doesn't matter whether it's wood, concrete, or any other building product. And there are some states now that have adopted legislation that basically requires the insurance industry to offer discounts. Interestingly enough, this is an insurance program, but there was the insurance companies, of course, didn't necessarily have to require a discount. They were just trying to reduce their risk. Now they're offering discounts, and that's a good thing. And these states, and we're trying to get this implemented in other states as well, using sort of model legislation that they develop for those states. In terms of mandatory adoption standards, either or optional for local adoption, which is probably more realistic. In other words, we're probably not going to get a standard adopted at the national level in the National Building Code that says you have to build this way. There's too many people against that concept. Builders would never allow it. Architects would never allow it because it squelches business. It likely squelches new construction. And none of us wins if that's the case. But if there are some standards whereby a local community can say, you know what, I want to build my buildings to a slightly higher standard, and here's how. And so, you can imagine, and thanks to PCA and all the efforts that they came up with, this is just a mock-up. They did it back in 2009, maybe even earlier than that, came up with this idea of taking the code and just taking the similar approach to what Fortified did and just adding additional requirements on top of the code. So you could see something like that happening where it becomes optional for a community. Empower advocacy, getting people involved in the code process. Again, it's painful, as you know. And it's out of most people's comfort zones. But we need to do it. It's the only way it's going to happen. And there are some great examples of where this has happened. San Francisco, they've adopted a soft story ordinance. So if you're familiar with San Francisco's soft story, these are wood buildings with a soft story because they have garages in the base. When an earthquake hits, they basically rack, right, on that lower level. Well, now, in San Francisco, they've adopted an ordinance that says, oh, you can't build this way anymore. In addition, you have to reinforce all the existing structures like this. And guess what? It's happening. Even had a loan program for building owners, and they decided, no, we'll just do it on our own. Because there were so many caveats on the loan program, apparently, that they're just going to do it on their own. Government taking action. Moore, Oklahoma, adopted a higher wind load. It's not perfect. I've looked at the statute. But it's better than nothing. We probably should have reviewed the safety standards. For the exit, there's only one exit out of this building, this room. New York, it's a great example. So Steve and I have been involved in New Jersey's fire recently. I don't know if you're familiar with the Edgewater apartment fire in New Jersey, 500,000 square foot wood apartment building burnt to the ground. And we're kind of looking, what can we do in the codes? Is there something we can do to maybe curtail this kind of construction? There's been a big backlash in New Jersey from people, especially those people who are now homeless from the fire, and discovered that New York City doesn't allow this type of construction. Oh, and guess what? New Jersey is the most densely populated state in the country. Now, I doubt that it's as densely populated as Manhattan. Well, I know it isn't, because I've done the calculations. It's not. But it's, all the surrounding counties and, the Bronx and Queens and Brooklyn and so forth, about the same kind of population density as those surrounding communities around New York City. So why wouldn't they do the same thing? What, are people not as important there in New Jersey? as they are in New York City. It just seems crazy to me that they haven't done that. So we're going to try to do that. As an industry, we're trying to get something in LEED to recognize that USGBC has been giving lip service to resilience for literally a decade, and they haven't done a thing about it. So we said, okay, here it is. Here's a pilot credit. Three different options. You can either do a very performance-based approach, demonstrate that you're lowering impact of materials by designing to a resilience standard over the lifetime of the structure. Fortified, that would be just not as worth as many points, but you would get some credits in LEED for designing a very prescriptive approach. Or there's another rating system for earthquakes specifically that you could use. Well, you know what? LEED has taken forever, or USGBC has taken forever to respond. They haven't said no. That's a positive, but they haven't said yes either. And it's been in front of them for over 2 years. I would say that the current administration is behind the concept because the President issued a climate action plan about a year ago, and the idea would be, one of the initiatives is to build stronger and safer communities, and NIST. Many concrete industry people are involved in this, as well as people from all other industries, to develop in the end, a community resilience guide that could eventually likely be turned into some sort of a code of some kind that could be, again, likely voluntary, but basically develop the framework for how one would design a resilient community. Other initiatives, there are pieces of legislation in Washington that our industry has sponsored or has asked legislators to sponsor. The Safe Building Code Act or Incentive Act that would increase disaster relief for latest codes, Disaster Savings and Resilient Construction Act that would provide tax credits for people who built to a higher standard, and the standard's well-defined, mostly fortified. The FEMA NFIP building code study that resulted in a report that said, in fact, if the flood insurance program required a building code to be in place, that they would in fact save money. So, it's getting there. Launching integrated dialogue, it's about telling people. There are some examples. Obviously, you can't read all this, but the idea here is that people are writing to their local newspaper or news agency, making sure that they understand that stronger building codes save lives, or they're advertising, whether it's positive or negative advertising. Either way, it's about getting the word out that, we need to build to a higher standard. And just other things like demonstration houses, show homes, all the things that people do to get the word out about a product. The other thing that this group said is that you focus on building science research. In other words, it can't be emotional. It's got to be science-based. I think most of the time the initiative is emotional, and then you have to go back and look at science-based. And FEMA has done a great job with a lot of documents on how to design to higher standards, or just high-performance criteria. Let's talk about how one can design it. And there are some companies out there, engineers, that have taken this to heart, mostly in the Southwest, where earthquakes are prevalent, obviously. And they become experts in being able to design a structure to a higher standard without a standard. So they've actually created their own process for designing to a higher standard because there doesn't exist. One doesn't exist. So what's the concept here? Well, you can build to just on the low end for lower performance, just to prevent collapse. The code typically is life safety, right? Just make sure people get out without the building collapse. For important buildings, hospitals, first responders, those kinds of structures, you will build to a higher standard. That's exactly what you do. You just multiply the loads by a factor. Not much else. It's kind of pretty simple. And then you might have to do some other things if you want to have it stay completely functional. And that's what these guys are talking about, these engineers. And the problem is, of course, it's hard to know how your building will respond to these kinds of disasters because there's not a lot of data. But ASIS, which is a FEMA program, does keep some data for earthquake, wind, and flood. Probably most for earthquake, but wind and flood, there's some data. So you can go in and you can actually do a performance-based approach where you say, okay, if my building is going to be subjected to this kind of loading now, larger than code, I can estimate what kind of damage it's going to have. Now I can estimate also what kind of impact on cost and on the environment it will have, or save if I design to a higher standard. Just a quick case study. This is something that I give all credit to a guy named Matthew Comer at Degenkolb. He's no longer with that group, but Degenkolb's a big engineering firm in San Francisco. And so he did a case study. He's done many, actually, but this is one that maybe is the easiest to understand. And basically designed a 5-story, 75,000 square foot office building in the Seattle area. So earthquake loading governs. And the systems that he considered for the design were concrete moment frame, concrete shear wall, and base isolated concrete shear wall. So 3 different kinds of systems that he was looking at. And the way he's measuring this, because it was kind of focused on sustainability, was that he did a life cycle analysis, an environmental life cycle analysis on the building to determine what the embodied impacts of the materials were for each one of the buildings. And then he estimated the cost of the damage caused and the cost of repair. So the top 2 lines are just the moment frame and the shear wall and the total embodied CO2 equivalent impact, so global warming potential. And then the earthquake damage caused by these different systems, moment frame, shear wall, and the equivalent damage from a base isolated shear wall building. And basically was able to calculate the annual seismic damage environmental impacts for the building based on a probability of those loads being, the building seeing those loads throughout its lifetime. And this is actually annual impacts, probability of annual impacts. So this could literally happen, well, in theory it could happen every year, but likely not. It could happen, but it could happen several times throughout the building's life cycle. And he was able to show that, in fact, in this case, great advertising for the base isolation systems, that they were able to save significantly by going to a base isolated concrete shear wall type system. So that's the kind of concept that these engineers are starting to look at and becoming experts at. I think it's a big problem right now is that, what owners are having a hard time understanding what benefit this brings. I think for critical structures, it's probably a pretty good approach, because now it's taking what was something very prescriptive in nature and bringing it into more of the performance realm, which I think needs to happen. Now, just last slide, incorporating hazard resistance into life cycle framework. I don't know how many of you are familiar with the work being done at MIT, thanks to funding from the NRMCA Research and Education Foundation. That's our research foundation, and the PCA come together to fund research, life cycle assessment and life cycle costing research. And basically what they're saying is that the life cycle total cost, both environmental and economic cost, is the addition of construction, right? So all the materials and manufacturing and transportation, everything that goes into building a building, plus the use phase, which is, of course, the longest and most impactful of any building. Then you have maintenance. Every building needs maintenance, and there's some environmental impact to that. Plus, there's this probability of damage from disasters, and they're working on that now, adding that into the total environmental impact. And so they should have some information about this about a year or so, a little less than a year. Sort of, again, turning this into more of a science as opposed to more of a prescriptive, let's just guess at what designing to a higher standard will result in, they're taking a more scientific approach. So you can quantify the benefits of designing to a higher standard. What does this all have to do with concrete? Well, again, for this stuff to happen, there's no guarantee. Concrete certainly has some qualities that would make it more resilient, but it's no guarantee. What really needs to happen is that the industry needs to rally around the idea of resilience and get involved in these different aspects in your community. Get involved in the climate change action plan in your community. It's really not all about climate change. It's about protecting a city from what will ultimately be likely a disaster. And so that's my message. Thank you.